So to celebrate the purchase of these octal sockets here that are for release but very handy for experimenting with octal tubes, I thought of using an octal tube, and in this case a PL36, to make another oscillator. Yes, another one. Anyways, this oscillator came up to be very powerful. It had a really long range for lighting up gas tubes, but I wanted also to make an HFVTTC. Actually, I never succeeded at making an HFVTTC with an oscillator schematic and single-ended with just one element, one amplifying element, so not push-pull. But now it worked. I made a very wide primary and a narrow secondary, and it was key to make this thing work. So what are the specs of this thing here? Okay, first of all, this thing is all magnetic. It has the same schematic, almost identical to a regular low-frequency VTTC. We have a secondary that isn't connected to the primary, we have a primary and a feedback coil, tickler coil as you call it. And the only difference is that we don't have a tank capacitor on the primary. In fact, the capacity is given by the stray capacity of the anode of the tube. This thing runs at 33 MHz measured, and we have a PL36 as tube. I run this thing at 800 volts out of my old friend of high voltage power supply. It is capable of 1.4 kilovolts at open circuit, but I run it less. We have a transformer for the heater of the tube, nothing special. It's a multi-purpose transformer, very handy. And we have a resistor for the grid 2 of the tube, 20K heat sinked, a capacitor to bypass the grid 2 of the tube. This is the grid leak network, and we have a bypass capacitor for the supply system, and that's basically it. But this thing has a pair of problems. Okay, first problem is that it's incredibly sensitive to tuning, like mental sensitive, because you have to match the resonant frequency of the secondary to the resonant frequency of the engine oscillator. To do this, I ballparked the secondary specs using Java TC, a calculator, to make a kind of 40 MHz secondary, and then I tried to put top loads, I tried to add tunes on the secondary, and initially I tried with a small neon bulb, putting it near it, letting it light up, and also with my hand, putting it near or far, to see if I have to increase the resonant frequency or lower it. And then when it made a flame at like 600 volts, I also adjusted the resonant frequency with the flame, looking at the flame with its sides. And anything is messing with the resonant frequency of this thing, the feedback coil as well. And to tune finally the sting, I have to move slightly the center windings, the center tunes of the secondary, slightly upwards to increase the resonant frequency, or slightly downwards to reduce it. And this already messes with the resonance. Or this connection here, bending this wire here, letting the primary go a bit higher or lower, and it already messes with this thing. Another problem is the supply voltage, because this thing apparently likes to run at 800 volts now. If I push the voltage more, it stutters, so I can't turbo mode this thing. Anyways, this is promising because the performance is pretty decent. I like it, and it was fun. Okay, let's try this thing. The tube is hot, the cathode is incandescent. You can maybe see, probably. Anyways, the variac is already adjusted with the correct voltage. We have now 237 volts SC. Let's provide the anode supply, and you can see the tube glowing blue. Very nice. This is the effect. The tube doesn't red plate, but the output electrode melts. Let's make it cool a bit. Also, the secondary is made ghetto style, so I don't trust much masking tape. Anyways, let's wait a bit for it to cool down, and let's try again. Power, and if I put my hand bit, you can see the effect becoming more or less tuned, because if I put my hand far away, the frequency is maybe too high on the secondary. At the middle level, the frequency is ideal, and more near, and the frequency is too low, and you can hear the sound varying. Let's try again. Power and go. You can also see the flame varying slightly in size. Let's try also with more light to have a flame with a more natural appearance. Okay, we have our screwdriver here. Power and go. And it's anyways too bright, but who cares? Smoke. Okay. If I suggest to replicate this thing, well, actually no, because it's quite complicated and the effect is relative at the end. If you want to make an HFVTTC, it's better if you use a classic schematic with like a GU50, I don't know, a bigger tube, so have a base fed secondary and capacitive feedback. It's probably better, easier to make. Anyways, if there are updates about this project, you'll find them down in the description of the video. And anyways, at this point, I think goodbye for now.